So some of my favorite reasoning type problems are the questions that are labeled always, sometimes, or never, because they make you think about, what all the possibilities are of a given situation. And so I wrote up 3 of them here, and on the assignment sheet, there are 3 of them as well for you to try. Hints that I can give you when you do these, try plugging numbers in, like if you're totally not sure what to do with it. That's always a good one. Also simplify or clean it up if at all possible. Okay, because like when I look at example 1, it says, is it always, sometimes, or never true that C plus D equals C when D equals 2? Okay, well, I can do some simplifying or some substituting here right off the bat because they're telling me D equals 2. So if I put a 2 in here, it's C plus 2 equals C. Okay, how often is it true that when you add 2 to a number, you get the same number you started with? Okay, hopefully that's never. Okay. Hopefully that's never, because there's no number that you can add 2 to and end up right back where you started. Okay, and that goes back to our original property. The only number that you can add that doesn't change the original number is 0. Okay, so our additive identity says 0 is the only number I can put here that would work. So this is never, ever, ever going to work. Okay. Example 2, A minus C equals C minus A. Okay, how often is that actually true? Okay. A good way to kind of separate your way through this, if something is, or actually a better way to think about it is, if you want to eliminate always true as an option, just find one example where it doesn't work. Okay, so can you find one example of an A and a C where this is not true? Okay, so let's say that A equals 3 and C equals 2. So 3 minus 2 equals 2 minus 3. No, definitely doesn't work. Okay, so it's definitely not always true. So now we're down to sometimes or never. Okay? If something's never going to be true, that means there's no examples that work. Okay, so never is just as easy to get rid of as always, because all you got to do for this to get rid of it is find one example that works. Then you're at least into sometimes territory. Okay, so is there any situation where it would work that A minus C is the same as C minus A? Yeah. Let's say that A equaled 2 and C equaled 2. Let's say they're the same number. So 2 minus 2 equals 2 minus 2. So yeah, so that works, which means it's not never because there's one example, but it's not always because there's one that doesn't, which makes it sometimes. So that is the very definition of something being true sometimes, is that you find at least one example that works and then at least one example that doesn't. Okay. And then the third one, okay, A plus negative A equals B plus negative B. So you could start listing off some A's and B's and testing them and seeing if you can eliminate any of these possibilities. But this is a good one for simplifying. Because what's A plus negative A? What's anything plus its opposite? Okay, well, we saw that over here. Anything plus its opposite is always 0. Equals anything else plus its opposite? 0. Okay, how often does a number equal itself? That is something that is always true. Okay, so they're kind of fun because they make you think a little bit abstractly, but either come up with examples or simplify it, or substitute, do whatever is there. It's available to you to kind of start eliminating some of those options.